Mastering hypothesis testing. Key concepts and techniques. Welcome to our in-depth guide on mastering hypothesis testing. In this copy, we will explore the key concepts and techniques essential for understanding and effectively utilizing hypothesis testing. Hypothesis testing plays a crucial role in scientific research and data analysis. It enables us to make informed decisions based on evidence and assess the validity of our assumptions. By properly applying hypothesis testing, we can draw meaningful conclusions and make accurate predictions. Let's start by understanding the fundamental concepts of hypothesis testing. Our journey will revolve around two key hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis represents the absence of a specific effect, while the alternative hypothesis suggests the presence of a significant effect. To conduct hypothesis testing, statisticians gather data and analyze the evidence thoroughly. They then compare the observed data with what would be expected under the null hypothesis. The resulting comparison helps determine whether the observed data supports or contradicts the null hypothesis. The next vital aspect of hypothesis testing is setting the significance level, also known as alpha A. This level indicates the threshold for accepting or rejecting the null hypothesis. Typically, a significance level of 0.05 is commonly used, suggesting a 5% chance of observing the data if the null hypothesis were true. Once the significance level is established, statisticians calculate the test statistic, a numerical value that summarizes
the evidence against
the null hypothesis. This test statistic follows a specific distribution, such as the t-distribution or the normal distribution, allowing statisticians to determine
the probability
associated with the observed data. To make a conclusive decision, researchers compare the p-value, which represents the probability
of obtaining results
as extreme as observed if the null hypothesis were true,
with the significance level.
If the p-value is lower than the significance level, we reject the null hypothesis in favor of the alternative hypothesis. Conversely, if the p-value is higher than the significance level, we fail to reject the null hypothesis. Understanding statistical power is equally critical when mastering hypothesis testing. Statistical power refers to the probability of correctly rejecting the null hypothesis when it is false. A high statistical power ensures that we can detect significant effects accurately. As we delve deeper into hypothesis testing, it is essential to recognize the potential errors that can occur. A type I error occurs when we reject the null hypothesis mistakenly. On the other hand, a type II error occurs when we fail to reject the null hypothesis when it is false. By minimizing these errors, we can enhance the reliability of our conclusions. In summary, mastering hypothesis testing is essential for any researcher or data analyst. By grasping the key concepts of the null and alternative hypotheses, setting a significance level, calculating test statistics, evaluating p-values, understanding statistical power, and recognizing potential errors, we can confidently draw accurate conclusions from our data. Now, armed with these key concepts and techniques, you are ready to embark on your journey to become a master of hypothesis testing. Happy testing!